DeepSeek V4 Flash, Qwen 3.8, and GLM 5.2 are three open-weight models chasing the same agentic coding crown, and I ran them through 5 tests that actually matter: agentic performance, coding capability, cost, speed, and tool use efficiency. Here's the surprise: the model that's up to 21 times cheaper on paper might not actually save you any money once you look at how many tokens it burns to get the job done. By the end of this video, you'll know exactly which one deserves your API key and which one's price tag is quietly lying to you. This is the test that decides whether your agent actually finishes the job or stalls halfway through a repo. On DeepSWE, DeepSeek V4 Flash and Qwen 3.8 are basically tied, 54.4 against 56.6, both vendor reported. Then there's Tool-Athlon verified, and DeepSeek V4 Flash is the only one of the three with a published number there at all, 70.3. That last point matters more than it looks. If nobody else is publishing a tool use score, you can't compare, and DeepSeek wins that round by default. Added up across the 3 benchmarks, and DeepSeek V4 Flash takes this test, with Qwen 3.8 close behind. On Terminal Bench 2.1, Qwen 3.8 takes the lead at 86.6, with DeepSeek V4 Flash at 82.7, and GLM 5.2 trailing at 81.0, though all three sit within 5 points of each other. A real cluster, not a blowout. Every one of these numbers is vendor reported, so treat the gaps as directional, not gospel. I went through every official doc, model card, and independent benchmark I could find for these three, separating what's measured from what's marketing. No hands-on testing here, just the clearest research synthesis I could put together. Raw coding chops tested 3 different ways. On SWE Bench verified, DeepSeek V4 Flash posts the strongest single number in this entire comparison, 79.0, and it's the only model with a published score on that specific benchmark. On Live Code Bench Passe 1, DeepSeek again is the only one with a figure, 91.6. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Where Qwen 3.8 shows up is SWE Bench Pro, the harder variant, where it scores 67.7 against GLM 5.2's 62.1, a clean 5.6 point win. Here's the complication. Community testing flagged a real build quality issue with DeepSeek V4 Flash on a flow graph test, scoring 60 out of 100 with a failed build. So the benchmark headline and the real-world experience don't fully agree. DeepSeek V4 Flash still takes this test on the strength of its SWE Bench and Live Code Bench numbers, but that community flag is worth remembering before you commit a whole workflow to it. This is where the story gets loud. DeepSeek V4 Flash charges 0.14 per million input tokens and 0.28 per million output tokens. Qwen 3.8 charges $2 and $6. GLM 5.2 sits in between at $1.40 and $4.40. That makes DeepSeek roughly 14 times cheaper than Qwen on input and 21 times cheaper on output. Cached input pushes the gap even further. DeepSeek at 0.0028 per million tokens against 0.25 for Qwen and 0.26 for GLM, close to a 90 times difference. Run the math at scale and it gets concrete. At 100 million input tokens a month, DeepSeek V4 Flash costs about $14 versus $200 for Qwen 3.8 and $140 for GLM 5.2. On sticker price alone, this isn't close. DeepSeek V4 Flash wins this test outright. But community reports say DeepSeek V4 Flash burns through more tokens to complete the same task, which means the real bill can end up a lot closer to its rivals than that headline number suggests. Keep that in your back pocket because it's coming back later. Stick with me because the last 4 tests are where this decision actually flips. Speed decides whether an agentic loop feels snappy or sluggish while it's chaining calls together. GLM 5.2 posts the fastest measured output speed of the three, 129.8 tokens per second, about 26% faster than DeepSeek V4 Flash's, roughly 103 tokens per second. DeepSeek claws back some ground on time to first token, answering in around 1.1 seconds on average, a strong number for anything interactive. Qwen 3.8 is the real gap here. There's no published throughput or time to first token figure for it in the FAQ registry, which is a notable absence for a model positioned as a coding agent. Between the two we can actually measure. GLM 5.2 takes this test on raw output speed. Multi-step tool use is where agentic coding actually lives or dies, and this is the thinnest test in the whole comparison. DeepSeek V4 Flash is the only model with a published Tool-Athlon verified score, 70.3. Qwen 3.8 and GLM 5.2 simply don't have a comparable figure available. DeepSeek V4 Flash takes this test by default, since it's the only one that showed up with a number. That's a transparency gap worth calling out on its own, not just a loss for the other two. DeepSeek V4 Flash wins on price by a wide margin, posts the strongest single coding score at 79.0 on SWE Bench verified, and is the only model with a published tool use benchmark. Qwen 3.8 leads Terminal Bench 2.1 at 86.6 and Deep SWE at 56.6, and it's the only one of the three confirmed to handle multimodal input. Plus it drops into Claude Code, Cursor, and OpenCode without changing your harness. GLM 5.2 doesn't win a benchmark test outright, but it's the fastest at 129.8 tokens per second and sits as the top open weight model on the Artificial Analysis Intelligence Index, with the broadest hosting footprint of the three. Now, DeepSeek V4 Flash wins on price by a wide margin, posts the strongest single coding score at 79.0 on SWE Bench verified, and is the only model with a published tool use benchmark. Qwen 3.8 leads Terminal Bench 2.1 at 86.6 and Deep SWE at 56.6, and it's the only one of the three confirmed to handle multimodal input. Plus it drops into Claude Code, Cursor, and OpenCode without changing your harness. GLM 5.2 doesn't win a benchmark test outright, but it's the fastest at 129.8 tokens per second and sits as the top open weight model on the Artificial Analysis Intelligence Index, with the broadest hosting footprint of the three. DeepSeek V4 Flash wins on price by a wide margin, posts the strongest single coding score at 79.0 on SWE Bench verified, and is the only model with a published tool use benchmark. Qwen 3.8 leads Terminal Bench 2.1 at 86.6 and Deep SWE at 56.6, and it's the only one of the three confirmed to handle multimodal input. Plus it drops into Claude Code, Cursor, and OpenCode without changing your harness. GLM 5.2 doesn't win a benchmark test outright, but it's the fastest at 129.8 tokens per second and sits as the top open weight model on the Artificial Analysis Intelligence Index, with the broadest hosting footprint of the three. For most people building agentic coding workflows, DeepSeek V4 Flash is the default pick. It's dramatically cheaper, it posts the strongest single coding number in this comparison, and it's the only model publishing a tool use score at all. If you need multimodal input or want a model that fits straight into your existing coding harness, Qwen 3.8 is the one to reach for. If raw output speed and the widest deployment ecosystem matter most to you, GLM 5.2 takes that lane. But the real question this whole comparison comes down to is whether DeepSeek's price advantage survives contact with reality, and on paper, right now, it does. That makes it the winner. Here's what the pricing page won't tell you. DeepSeek V4 Flash looks like it's up to 21 times cheaper than Qwen 3.8, but community reports say it consumes more tokens to complete the same task. That means the real invoice at the end of the month can land a lot closer to its rivals than the 0.14 and 0.28 headline numbers suggest. Before you migrate a whole production workflow on price alone, run your own token count on a real task. The sticker price is real. Whether it stays that cheap in practice is the actual open question. If you want to see how these three stack up against the closed source models everyone's still paying full price for, that comparison is coming next, and it's the one that decides whether open weight has actually caught up.